All right. Hello, everyone. Sorry, little issue with the screen there. Okay, so today we're going to talk about 10.6. This section is about secants, tangents, and angle measures. A secant is a line that intersects a circle at exactly 2 points. So this line FG intersects at P and Q. So PQ or FG, that is a secant. There are several ways secants and tangents can intersect. The angles and arcs that are formed have different relationships. So there's a lot of different formulas and pictures you're going to be seeing in this section. So we're going to try our best to give you the formulas and explain the pictures for each one. So the first thing you may see is an intersection on or inside the circle. It looks like an X. If this is happening, it's two secants intersecting in the interior of a circle. If this happens, the measure of the angle formed is 1/2 of the sum of the two measures of the arcs. So this angle 1, okay, and obviously this is also equal to angle 1. Those are vertical angles, just pointing that out. The measure of that angle is 1/2 of arc PR plus arc SQ, okay? So that's a basic formula for you here. Now let's take a look at an actual problem. So if I look here, I'm trying to find angle 1. The measure of angle 1 should equal 1/2 of that arc plus the other arc. So they're both given to me here, which makes it pretty easy. So I'm just adding 52 and 40. That's 92, and then I take 1/2 of that, and that would be 46. So my angle 1 is 46 degrees. This one's a little trickier. Okay, they're giving me both of these angles, okay, but they want me to find this one. Now, these are the intercepted arcs of, if I call this angle 1. Those two arcs would work for angle 1. So why don't I try to find angle 1 first, and then maybe it will help me get to find angle 5, okay? So if I was trying to find angle 1, I would do 1/2 of 130 plus 90. That's 220. And 1/2 of 220 is 110. So that's not my final answer. That means that this is 110 and this is 110. Okay, but I do know that a whole circle is 360. So it's very important to remember here that a whole circle is 360. So the two measures I put in for angle 5, this should be the same thing. This should also be this equivalent to angle 5 because they're vertical angles. Whatever I put in there has got to add to 360 with this 110, these two 110s. So I'm going to do 360 minus 220 because that's the two 110s together. And when I do that, I get 140. 140 should be split evenly between these two angles. So I'm going to divide by 2 and I get 70. Angle 5 would be 70. So I'm using my knowledge of this theorem to solve this, but I couldn't actually figure out what these two arcs would be because they're not necessarily an even split like the angles are. The angles have to be equivalent because they're vertical. These arcs don't have to be equivalent. So I couldn't have said 360 minus 130 and 90. I couldn't have found a logical reason for that, but I could go backwards and find these missing angles first. Okay. All right, the next type of picture you may see is if a secant and a tangent intersect at the point of tangency, then the measure of each angle is 1/2 the measure of its intercepted arc. So this is your tangent. This is your secant. Your secant intersects at 2 points. Your tangent intersects at 1. They are intersecting each other, and this they have an intercepted arc. So this would be, they're saying if you're trying to find angle XTV, this angle, then your intercepted arc would be this one, TUV. Okay. If you were trying to find this angle YTV, then your intercepted arc would be this one. Okay. So you're just taking 1/2 of that arc to find the angle. So in this picture here, I want to find angle 3. So I'm just going to do 1/2 of the arc, which is 220. So I get 110. That's my angle 3. Okay. Over here, I have 6. They want me to find this they want me to find angle 6, which means I would need this arc. They gave me this arc. That's not super helpful to me, so I need to, but I can figure out what this arc is because I know that a whole circle is 360. So I'm going to do 360 minus 160. That gives me 200. That means this arc is 200. Now that's not the question though. They want to know this angle. So now I know that this angle should be half of 200, half of that arc. So my angle 6 would be 100 degrees. Okay. All right, moving on to the back side here. This is where it gets a little crazy. We have a lot of different formulas being thrown at us here. So please focus on this side. So now we have intersections outside the circle. So there's a few different ways this is going to look. So it kind of breaks it down for you here, and then down here on the numbers, the exercises, I'm going to label which one they're talking about. Are they talking, is this a 2 secant picture? Is it a secant and tangent, or is it 2 tangents? The biggest way I identify between a secant and a tangent is a secant hits at 2 points on the circle, a tangent hits at 1. So AB right here is a secant, DE is 2. HJ is secant, OG, is that a Q? Sorry, QG is a tangent. These are both tangents because they hit the circle at 1 point. So there's different formulas for different types of pictures we're going to see. With a 2 secant, you're going to do half. So if we're talking about angle P, in order to find angle P, you would do half of this bigger arc minus the smaller arc, AD. If you're doing secant and a tangent, you would do, if you're trying to find angle Q, you do half of this bigger arc minus the smaller arc. Okay, so it's, and then here we have 2 tangents. To find angle R, you would do half of the bigger arc minus the smaller arc. One thing I just want you to remember here in all of these is that a circle in full equals 360. That can be important because for some of these, they may only give you one of the arcs, especially in this problem here. These two, this smaller arc and bigger arc, should add to 360. It's a whole circle. So they may only give you one of them and you may need both. So they may expect you to be able to find it. Okay, so looking at this first picture, angle 1, this is a 2 secant problem. So I'm just going to go through and label these first. This is 2 secant, looks just like that. This one has 1 tangent and 1 secant. This one here looks like a cone. Anytime they look like an ice cream cone, it's 2 tangents. It only hits the circle once. And here's another ice cream cone. It's 2 tangents. All right, now we're ready to solve here. So to find angle 1, I'm going in the 2 secant problem, which is here. I am going to do, to find angle 1, I'm going to do half of the bigger one minus the smaller arc. So that's half of 40, which is 20 degrees. Okay. Now I'm going to do this secant and tangent. That's this problem here. I'm going to zoom out a little bit for you. Okay. So in order to find angle 2, angle 2, I'm going to do 1/2 of my bigger arc, 160, minus my smaller arc, 80. For some reason, you cannot see my screen right now. Okay, we're back in business. So that would be half of 80, which is 40 degrees. Okay, moving down here to our 2 tangent problems. This is where I'm talking about the 360. You are missing an angle, 3. You're also missing this small arc. Okay. You need to have both of those. So I'm doing some strange things. Okay, we're good. So I need to do 360 minus 220 here. That gives me 140. So that means this is 140. Now I can use that formula. Angle 3 equals 220 minus 140. So angle 3 would be, and it's half of that, sorry, half of 80, which is be 40 degrees. Okay, last one here. The last one here is the two tangents. Okay, very last thing here is the two tangents. This whole thing should be 360. This is a tough one, okay, because you're doing, you know that 50 is the angle, and half of that angle should equal something minus x. We don't know this something. It's really just 360 minus x, right? Because the rest of this should be whatever is left from 360 when we take away that x. So when I simplify that algebraically, I get 360 minus 2x. Half of 360 is 180. Half of negative 2 is negative 1. Then I'm going to subtract 180. I get negative 130 equals negative 1x. So x is 130 degrees. If you have any questions, please jump on my video chat. Okay, have a great day, guys.